Hi again. This is the last segment of reviewing interest theory. So in this last segment, we'll take a few points about annuities, some little insights that will help us for the next treatment of the material. All right. So what I wanted to talk about is firstly, let's start with some useful relationships. So some useful relationships between like how we can use like different types of annuities to answer certain questions. So what I wanted you to think of this example, right? So here you have from 0, you have to n, right, the usual story, and then we add n plus k. There is another period called k. So if you visualize it, this period will be k and this period will be n, the typical n, right? So now we need to create the relationship between a angle n plus k. So the one for the big thing, right, for the whole period, right? And we know what this one, it pays 1 1 1 2, it pays 1 1, right? Here 1 1, right? And because it's the end of the period, the last one will be here, right? So this one, we need to relate it or to split it between both of them, between n and k. So what we would know that we can add an, and then we need to add a k, right? I left little space here just to think through it, what we need to make this equality. So if we take the year of evaluation is this year, right? We wanted to take this year as the year of evaluation, right? So this one here can be, if we evaluate here, so an does not require any treatment, right? But a angle k is here. So we need to bring it back. Right? So this one, how we bring it back, we have Vn, right? Vn ak. So a angle n, it can be Vn k. Let's take one example just to see if we can use this little relationship. So we have, instead of like we have a5, it's given to us in already computed for you. It's 4 2 1 2 3. And let's say v5 is equal to 0 7 4 7 2 5 8. Right? This one example. And what we wanted to find is to find a angle 10. Right? So a angle 10, I mean, there are several ways. One, the harder way is from here you can find I, and then once you find I, you find a10 directly. It's easy, it's not very difficult, right? But we wanted to use this relationship, so this is one way. Alternatively, I mean, you can verify it yourself, but we can recognize that a10, sorry, is equal a5, right? So the 10, the period of 10, 0, 5, 10, you split it into 5 plus 5, right? N, K. So plus V to 5, A to another 5, right? And A to 5, we don't need to compute anything. It's given to us to be 4.2123 plus 0, 7, 4, 7, 2, 5, 8 multiplied by another 5, 4.2123. And if you use your calculator, which I will do quickly, so we have 4.2123 plus 0.747258 multiplied by the same 4. So this is what I got, which is equal to 7.3, 36, you can say. Right? I mean, you can verify it if you want. You can verify it using this relationship, right? You can verify it just if you wanted to double check it, or you can move forward. I mean, there are always in interest theory in particular, there are many ways that you can compute the same equation. Try to find the most efficient way, because especially for those who wanted to take the actuarial exam for actuarial math, time matters. Time does matter. So you need to be very efficient to save time, right? So I mean, there are several ways that how you can compute it. You can evaluate at this point as well, so you calculate S5 and A5, right? Take another example here. But the other example, instead of my handwriting is really bad, I already typed it in, but just I need my mouse to be moving. And I will have it as image, so we can no, not this one. I think I need to add an image here, library image, and this one, right? So this one, oh, it's so small, so I need to get it bigger. Oh, still small. I can make it a little bit bigger so we can read it, right? Let's look at this equation. So this question is not $1. Here we have 5,000, right? It's the same logic, 5,000 on $1, always you can multiply. So we need to, somebody here is, you will deposit 5,000. So the amount you deposit in a bank at the beginning of this year and the following 2 years. Let's visualize it. 0, 1, 2. It says, very important to recognize that at the beginning. It's very important. So 5,000 here. Let's have an arrow to know its deposit at the beginning of this year and the following 2 years. So the following at the beginning of the following 2 years. So at the beginning of this year and the following 2 years, right? We have another 5,000 here and then another 5,000 here. This should be clear, right? Right? So the language of the question is very important to really pay attention to it, right? So at the beginning of this year and the next 2 years, at the end of year of the last deposit, so the end of the year of last deposit we deposited here, so the end of the year of last deposit here, you will start with drawing level payment of P. So P, because it says here, wanted you to see that here it's saying at the end, right? And this will start with the payment of each of the next 5 years. So we have 5 payments in total, right? So if you do 4, 5, 6, 7, at the end of the first, this is the first one. Second one, we take another P at the end of each year, P, another P. Count them 1, 2, 3, 4, 5, right? Because for the next 5 years. So let's read it one more time. At the end of year of last deposit you made, you will start withdrawing level payment for each of the next 5 years, right? So this is like the hardest part of this equation is really to draw it, right? Once you have a good image, then it becomes mechanical. You know the formulas, you can quickly. Second thing is you need to find the year of evaluation. You can evaluate at time 0. I would rather evaluate at this point. It saves a little bit of time, right? So if like this is year of evaluation, let's say. You can do it here, you can do it here, wherever you want. In actuary, in financial mathematics, you can do whatever you want, the year of evaluation. So if you have 5,000, now if you recognize 1, 2, 3, 3 payment, let's make it A angle, A3, right? And we bring it here. I wanted you to recognize it's the beginning of the year, so it has to be due. Right? Do you see it? Because it's the beginning of the year. This must be equated with P. The year of evaluation is here. And the payment is made at the beginning, even if the question says at the end, but because we selected this year as the evaluation year. So at the beginning of this year, if we evaluated, oh, my cat is, yeah. All right, so at the beginning of at the beginning of the year, from the image here, we can see this. We need also, oh, here, sorry, I made a mistake here, right? Because this is, we evaluate here, so this will be S. Sorry, because we accumulate, we bringing this series of payment, we bringing it here. And this series of payment, these guys, we bring them here, right? Let me use the same color so we can see, right? So we easy to make mistake here, but we need to focus, right? So the year of evaluation, because this is made at the beginning of the year, it's like the accumulation, but because the beginning of the year, we use the 2 dots, right? Want you to remember this. So now P, now we taking present value, we bring it back. So now P will be A for 5, because we bringing to the first year, so year 8 will be 0, right? So for 5, right? And this is very important, you know, to recognize this kind of relationship, right? It's very important for us to make sure that we have the correct formula for this one, right? Do we see it, right? Because we evaluated at this point. So now it's simple, because you have I should be, the question give us I, which is 6%. So S3 equal, remember the formula, you can calculate A angle 3, or you just, if you remember it, is 1 plus I raised to 3 minus 1 divided by I, but because we have 2 dots, let me create space here. Everything here we need to multiply it by 1 plus I, right? This, I mean, any formula you wanted to use, you can use. So we have 1.6 raised to 3. We subtract 1 from it, divided by, again, by 0.6, multiply it by 1.06. I got to 3.374616. Try it yourself. I assume that, as we discussed in the very first lecture, you need to do the questions yourself, and I'm using calculator. It slows me down, so you can take your time to calculate. If it happens that you need time, you pause, right? You pause to double check. Right? Did you get this number? Right? You get this number? Did I get it right? I think it should be right. Right? So yeah, I think it should be right. And now let's look at A5. I didn't have that. Yeah, A5. Now this is A angle 5, because remember we're bringing back everything to this point. A angle 5 is now 1 minus, this is immediate also, Vn, which is V to 5 divided by I. Everything is multiplied by 1 plus I, right? Because this is, remember the dot. And simple enough, this is what, I mean, I usually use the calculator immediately. So I have 1.06 raised to minus 5, subtracted from 1, divided by I, which is 0.06, multiply by 1.06. I got this guy to be 4.4651, right? So yeah, I mean, this is what I got here. So now what we wanted to do is, we have everything needed. So now we take this one here, so it becomes 5,000, multiply by 3.374616. And this is, I do it immediately in the calculator because I kept the answers here, so I don't need to do it again. Multiply by 5,000. This will give us 16873.08, and this will have to be equated to P multiplied by 4651. 44. So P is take this guy, you divide it by this guy. I get it right. So I got this one to be 3778.87, right? This is the amount of payment that will equate it, right? Always use your calculator, right? Try to keep all numbers in the calculator so we can always verify, right? So now let's move on this relationships now. So let's take like something that you know, like, yeah, I hate those formulas. You don't need to memorize all of them, but sometimes you have like we talked about annuity that pays level amount 1 1 1 or P P P, you know, right? This kind of annuity. But what if you have annuity that is not level, right? So annuity that is like different values. So let's start with one with a pattern, increasing annuity. And increasing annuity, just let's imagine that you have this your line 1 2 all the way to n, or this gives you 1 2 all the way to n, it gives you n. Now if you want to have the present value of this annuity, it will be v, right, plus 2v2 plus nvn, right? There is like a way also to use the geometric series. You take the derivative of it, but let's go directly to summation of this one. We'll use this notation. I for increasing, a, it's to say that is annuity, and without dots to say it's at the end of the year, angle n, right? And this is something really, this one need to memorize it. Maybe it's just some handy. I mean, you can derive it yourself, but it's good to memorize it. NVN divided by I. So you need to be careful here, right? Because here you have a dot dot n. What's in the denominator is I, always with a, would you usually have I, right? But this is what you need to remember, right? So I always memorize this one. The rest you don't need to memorize them because you can always, you know, derive them. So what if you wanted to have a, I, n, and this is, instead of paying $1 here, it will pay you 0 1 2, starting here, 2 3, then you have n, you will have n minus 1, the payment, right? Do you see the difference between this and this, right? Because you start at the beginning of the year. So the easiest way to remember this one is simply like this one related to that one by knowing that this is as if there is one step backward, right? Anyway, so you need to bring it back. So anyways, the best thing is to say 1 plus I with I, a, n. I wouldn't do too much, you know, like I would just know this one, and then this one I can derive it quickly, right? Because always the relationship between the immediate, the due and immediate is you multiply this one with 1 plus I, right? You can also, I mean, there are several ways that you can think about it. You can also think about it instead of I in the denominator, it can be same formula here, a angle n, nvn. Instead of I, you have d in the denominator, right? So it's the same like formula, right? You can memorize, you know, as much as you wanted out of these guys, you know, but just like try to not to overkill it. Just one of them is enough, and then you can drive the others. So for instance, you wanted is angle n. First, you recognize there's no dots here, so it's the same thing. It's, you have again 1 plus I, you raise it to n, multiply by a angle n, right? This is, remember, s, what is s? Is the future value, right? So you evaluate, instead of you evaluate at the beginning of the year, Instead of evaluate the present value, you take the future value, right? Same as in the previous lesson on annuity, right? What if you wanted to have is same, and plus I raised to n multiplied by I a n, right? Same logic. There is not much, you know, don't need to do much of these things here, right? Right? Let's not overkill it, you know. What about decreasing annuity? Decreasing annuity, the logic is you have 0, 1, 2, 3, all to n. So decreasing annuity, it gives you, now instead of $1, it gives you n minus 1. So the last one will be 0. Nothing left, right? So the last one will be you consume all your actually no, the last one will be 1, sorry. Right. Yeah, the last one will be 1, right? Because it will be n minus, yeah, last one will be 1, right? So this, the decreasing annuity is simple. You don't need to do much about it, right? You don't need to do much about it. So n minus 1, right? So you don't need to do much about this annuity, in the sense that it's the same logic we applied before, dA. We memorize the first one, and then it's n minus an. You see, there is no dots here, just helps you to understand it, divided by I, right? This one you can memorize it, and then you derive the rest of them. So the rest of them, dA, oh sorry, angle n, dA angle n. How we do that? It's simple. It's 1 plus I multiplied by dA, sorry, right? So you know one, and you can also replace I with D, the same logic. You can also say n a angle n divided by, instead of ID, right? It's the same logic. There is not much things to do. But what if you wanted ds angle n? It's simple. N, sorry, 1 plus I raised to n, and then you look at what type of s here. It becomes then instead, because this is accumulation, it becomes dA angle n, right? Not much. If you do ds angle n, it will become 1 plus I raised to n, instead of instead of ds, it becomes dA, but we also with dots angle n, right? So like those, you just really, again, you don't need to memorize all of them. It's just like you memorize what one of them, or one of the increasing, one of the decreasing, and you derive the rest. Not much of things to do. I'll not give you examples, just like good to review them quickly. Usually, and why I will not give you example, usually in questions like this, you will be given a few terms, and then you can quickly compute it without even any formula. Just you can calculate it from the very basic idea of discounting. You discount each term. Let's take, you know, one example, general example, and since it's maybe it's easier, my handwriting is really bad, so let me get a picture for this one, like what I did before. I already saved it as picture. Let me take this guy here. I want you to take 1 minute to read it, pause me, and so you can read the question carefully. Want you to, again, like to start solving the question yourself and then compare your answer with my answer. Okay, assuming that you did a try. So now let me start working on this one. So it's very important to read it carefully. We need to read the question very, very carefully, right? Let's read it carefully together and see what's going on here. So you have an annuity that pays for, at the end, important, right? At the end of each year for the next 4 years. Let's draw it. So an annuity that gives you 4 at the end right? At the end. It's not at the beginning. It's not here. At the end of the each year of the next 4 years. 4, 4, 4. Did we get that? It's straightforward. Let's see. Let's see what's next. And then $2 at the end of each year of the following 4 years. So we have another 4 years. 5, 6, 7, 8. But this now gives you 2, 2, 2, 2, right? At the end. This question, there are several ways how you can answer it. You answer it based on what the information is given to you. So you use what's given to you to answer the question. So what's given to us is this guy and this guy. There is one way that you can calculate I and then you calculate everything else, right? If you get I. But what I will do, I will try to make use of this one for efficiency to have, more efficient, like save some time. So if you look at this one, we have A4. And remember, we have a relationship between A, K plus AN. So the amount here is not equal, it's decreasing, right? So instead of using those complicated formulas of decreasing, increasing, we use just like the very basic idea. So the present value of this special annuity is simply you take the 4, right? And you take the 4, you multiply it by A4, which is good because at the end of the year. So here A4, and then plus 2 with another A4, A angle 4, right? But this 2 is here. It gives us here. We need to bring it back to here. How we bring it back to here is simply we have V4, right? It's so simple. It's so simple. Let's use a calculator. So you have 4 and, sorry, where I was. So you have 4 times 3.546 plus 0.8227 multiplied by 2 multiplied by what else? The same 3.546. Right? If you do that, I mean, let's do it quickly here. 4 multiplied by 3.546 plus 0.822 multiplied by 2 multiplied by 3.546. I got here, 20,018. Did I get it right? Just let me think. I made a little mistake here. It should be okay. Let me try to see. 3.46. Yeah, it's okay. Right. So this is what I got. Actually, 1.3 or 1.4. There is, if you want to do another way also to just like as visualization. Imagine if you are, let's think about it also just for alternative way. As I said, alternative way, you can calculate I and then you calculate everything else. There is also just like the present value can, just like as curiosity, is imagine if you have A angle 8, right? If you have A angle 8, so what I would do is simply I will do 4 A angle 8 and subtract from it 2V4 A angle 4. Right? And if you like this alternatively, right? It depends on what you are given, but just like I'm trying to like give you different ways to do the same, to answer the same questions. All right, with this we guys, good that with this one we already finished. Oh, my mouse is not working. Yeah, with this we finished the review of interest theory and probability. As I said before, actuarial science is the combination of probability theory and interest theory. In probability theory is the likelihood of an event to happen. In interest theory is you bring the money. So now in actuarial math is the probability, like a contingent, or like the payment, the present value is you take it contingent on another probability. So that's the combination between them. It's all about actuarial math. So next session we'll start getting into some new notations new to you guys on actuarial mathematics. All right, take care.